Dear students, greetings for the day. Today we are going to discuss the projectile motion from the dynamics part. As physics is a broad subject, it is divided into several branches. So dynamics is also one of the important branch. So in this dynamics, kinematics is the first one. We know that every body will present in either of the two states, rest or motion. When a body does not change its position with respect to time and surroundings, then it is said to be at rest. If the position of the body changes with respect to time and surroundings, then it is said to be in motion. When the position of the body is changing and when it is present at different positions at different timings, then the line joining the different positions is called path traversed by it, or the total length of the path is called distance, and the change of position of a body in a particular direction is known as displacement. It is a vector. Distance is a scalar, but both have same unit in SI system, meter. And when there is a change in displacement, rate of displacement is called velocity, or change of position of a body in a given time is called speed, as it is not possess a specific direction. Speed is a scalar quantity, whereas velocity is a vector quantity. Both have same units and dimensions, meter per second. L to the power minus 1 is its dimensional formula. And when the velocity of the body changes, then rate of change of velocity is called acceleration. So acceleration A bar is equal to change in velocity by time, that is v minus u by t. So now let us recapitulate the equation of motion. So when the position of the body changes with respect to time, then it is said to be in motion. The motion of the body is governed by certain laws. So the laws of motion or equation of motion are stated as v equal to u plus at. And for example, when a body is moving with initial velocity u, then it acquires an acceleration a bar in time t. After time t, let its final velocity be v bar. Then expression for final velocity is v bar equal to e bar plus at bar. Second one, expression for displacement. So it is given by ut plus half at square. So when a body starts with initial velocity u bar, let it acquires acceleration a bar in time t, and in time t let the distance travelled by the body be s bar. Then expression for displacement is s equal to ut into ut plus half at square. Third one equation is v square equal to e square plus 2as. So This expression also gives the final velocity. It connects the initial velocity, acceleration, distance and final velocity. So acceleration a bar here. Final velocity v is obtained by taking square root of u square plus 2as. And fourth equation, distance travelled by the body in the nth second, last second of its journey. So it is denoted by Sn is equal to u plus a by 2 into 2n minus 1 or u plus a into n minus half. So these are known as equation of motion. Now generally when the body moves, then we apply these equations for finding the any unknown quantity when the others are given. Now when the body is moving in air, then it is called projectile. So when the body is projected into air with some velocity in the vertically upward direction, then for every second its velocity decreases by 9.8 meters per second, and as it moves up, finally after reaching certain height its velocity becomes 0, and the body, due to gravity, it is attracted by the earth, so again it returns to earth. So here, as the body moves up, its velocity gradually decreases. So the body which is moving in the upward direction, it possesses negative acceleration. When the body falling from maximum height, after reaching the maximum height, its velocity is 0. Then when it comes down, returning to the earth, then its velocity gradually increases from 0. For every second, its velocity increases by 9.8 meter per second for every second. So the body acquires an acceleration 9.8 meters per second square constantly, and this acceleration is due to the gravitational pull of the earth. So the acceleration produced in the freely falling body is called acceleration due to gravity, and this acceleration due to gravity is denoted by g bar. Small g bar. It is a vector quantity. It possesses magnitude and direction is towards the center of the earth. Generally its value is taken as in SI system 9.8 meters per second square, in CGS system 980 centimeter per second square, in FPS system 32 foot per second square. Now we take SI system only here. So now equation of motion under gravity, we discuss under gravity. So when the body is moving up, it is projected with certain initial velocity u bar, initial velocity u bar. Then here acceleration a bar is equal to, as the body moves up, its velocity gradually decreases. So it possesses negative acceleration. Therefore, a bar is replaced by minus g. Therefore, then this equation becomes v bar is equal to u bar minus gt. And this equation becomes s equal to ut minus half gt square. And this third equation becomes v square equal to u square minus 2gs or v square minus u square equal to minus 2gs. And this equation becomes Sn is equal to u plus u minus g by 2 into 2n minus 1. And this is the same one is equal to Sn is equal to u minus g into n minus half. So these are the equation of motion under gravity. When the body is in air and moves in vertically upward, then we use these equations instead of the first four one. Now when the body is moving from maximum height with zero velocity and moving towards the earth, then its velocity u is equal to 0. Therefore, when the body is returning to the earth, moving downwards, u equal to initial velocity 0 at maximum height. Acceleration is taken as plus g as its velocity gradually increases for every second 9.8 meters per second. Now in this case, this equation becomes v equal to gt and s equal to, since u equal to 0, s equal to half gt square and v square equal to 2as. Here 2as becomes 2gs. And Sn is equal to g into 2n minus 1 or Sn is equal to g into n minus half. So these are the equation of motion under gravity when the body is moving down from maximum height where its initial velocity is equal to 0 and acceleration is equal to positive acceleration plus g value. Now let us know the parameters of a vertically projected body. First one, let us calculate the maximum height reached by the vertically projected wire. Estimated by H maximum. And the body is moving up here. And the body is moving up with initial velocity u equal to u, and acceleration a is equal to here minus g. On reaching the maximum height, at maximum height its final velocity v equal to 0. Now here the distance travelled by the body, here s equal to h maximum. So consider a body which is projected with initial velocity u in the upward direction, and as it moves its acceleration a is equal to minus g, and on reaching the maximum height its final velocity is 0, and the distance travelled by the body on reaching its maximum height, let it be s equal to h maximum. Let us calculate the maximum height reached by the body. From the equation of motion, v square minus u square equal to 2as. V square is here 0 square minus u square equal to 2 into minus g. As the body is moving up, s equal to h maximum, let it be. Therefore, minus 2g maximum when it comes to right hand side. 2gh maximum is equal to, when we take this to this side, h maximum is equal to u square by 2g. So this is the expression for maximum height reached by the vertically projected body. Now let us calculate the time taken to reach the maximum height, that is from A to B, from ground to maximum height B. Now here t equal to time of ascent. Time taken to reach the maximum height is known as time of ascent. So here t equal to ta, time of ascent. Now let us calculate the value of ta. Time of ascent, time taken to reach the maximum height. Here u equal to u, a equal to minus g, and v equal to 0, t equal to ta question mark. So here, so from the equation v equal to u plus at, v is 0, u equal to u, a is equal to minus g, and t equal to ta. Here from this, gta is equal to u, or time of ascent TA is equal to u by g. So the time taken to reach the maximum height TA is equal to u by g, and the time taken by the body from maximum height to reach the ground again, it takes the same time, and it is called known as time of descent. Time taken to reach the ground. From maximum height is known as TD. So from maximum height when it returns to ground, A is equal to plus G and S equal to H maximum. Therefore, from S equal to ut plus half at square, S is H maximum, U is 0, therefore half 0 into T 0, half G into T means time taken to reach the ground. Therefore, from this expression TD is equal to 2H maximum by so TD is equal to, but we know that H maximum is U square by 2G. Therefore, root 2 by G into U square by 2G. 2 gets cancelled, U square by G square. Therefore, this is equal to U by G. So, time of ascent is equal to time of descent. So, TA is equal to U by G. TD is also equal to U by G. So, therefore, time of ascent is equal to time of descent. Now, total journey time is, that is the body remains in air. The time for which the body remains in air is equal to time of ascent plus time of descent. That is U by G plus U by G. That is 2U by G. That is called time of flight. Total journey time. It is represented by capital T. So in the case of vertical projection, it is equal to 2U by G. Now let us discuss about the horizontal projection, horizontally projected body. That is horizontal projection. Our main topic is this one. And now we recapitulated the fundamentals. Till now we discussed the vertical projection. Now when we consider the projection, angle of projection, here in this vertical projection case, theta is equal to 90 degrees, but in the case of horizontal projection, it is equal to 0 degrees. So when the body is moving parallel to the earth, then the body is said to be horizontally projected. For example, bullet released from the gun generally moves parallel to the earth. So in horizontal projection, the body is projected with certain initial velocity u. So when the body is here, there are two types of projections when compared to other than the vertical projection. The body is projected in horizontal projection and in oblique projection. In horizontal projection, the body is moving parallel to the earth, that is theta equal to 0. And when the body is moving at an angle to the x-axis, then it is other than 90 is known as oblique projection. Now we discuss in detail horizontal projection of the body, horizontally projected body. So what is projectile? First we know definition, projectile definition. What is projectile? Projectile is a bow. A body which is projected into air. With some initial velocity at an angle to the horizontal. And is allowed to move freely under the force of gravity. Here, so the angle to the horizontal made by the is other than 90, then it is called oblique projectile, or when it is theta equal to 0, then it is horizontal projection. When theta is equal to 0, here when theta equal to 0 degrees, then the projection is known as horizontal projection. Examples: water released from horizontal tap. Next, bullet released in horizontal direction. And for projectiles, oblique projectiles, when the body projected into air with some angle to the horizontal, it is known as oblique projectile. And when the, so here in this case the body falls like this to the ground, and when we oblique projectile case, the body is moving like this. It is projected with some angle to the horizontal. So when a body is projected into air with some angle to the horizontal direction, then it is called oblique projectile or simply called projectile. Now first we discuss the horizontal projection. When we project the body in the horizontal direction, then what is the distance traveled, horizontal distance traveled and vertical distance traveled by the body? And show the, we shall show the path of the projectile is always follows the parabolic path. So in this case, parabola, this is the shape, and when the body is traveling in the horizontal direction, after a certain time it reaches to the ground, it falls like this. So this is also parabolic path, parabola traveling from origin. So this is the vertical distance traveled, this is the horizontal distance traveled by the body. It is vertical distance is called height of the body. Now let us show that the path of the projectile is parabola. Now we shall derive the expression for the path of the projectile, and it resembles the equation of parabola. For example, let us consider a body which is projected into air with initial velocity u parallel to the earth. As it moves in the forward direction, as it moves in the forward direction, it gradually moves towards the earth as G is acting, its weight is acting vertically downwards towards the center of the earth. So as G is acting in the vertically downward direction, so here vertical, it is called height of the AB, height from where the body is projected in the horizontal direction. So here vertical direction is in the y-axis direction, and as it moves, it is called horizontal range. Horizontal distance travelled by the body is known as horizontal range. Let it be x. Here it is equal to u into horizontal velocity. Let this be point C. A to C is x, and let this be y. Equal, since this distance is in the y direction. So consider a body of mass or any particle from B. When it is projected in the horizontal direction, as it moves in the forward direction, then it gradually, its height decreases because gravitation acts vertically downwards. Therefore, when it reaches to the point at C, it touches the ground. Here, so in vertical direction only G acts. In horizontal, when the body moves in horizontal direction, that any point in its path traveling with the same as there is no effect of G on horizontal direction. It always travels with equal velocity U. So horizontal velocity does not change with here gravity. So it remains same at any point in its path. So here, what is the horizontal distance traveled? Horizontal distance traveled by the horizontally projected, that is A to C, XRAC is equal to U into T, velocity into time, or from this expression T is equal to X by U. Let's use this first equation whenever we require the value of T for substitution. Next, vertical distance traveled from B is in y-axis vertically downward direction, that is in y-axis direction from B to A. That is height of the body, which is at height h, and vertical distance s is equal to h, or let it be also y. Vertical distance traveled P s equal to y equal to h. Let us calculate from the equation s equal to ut plus half gt square. Here, when it starts its journey, vertical velocity here at this point is vertically downward, u equal to 0. So initial velocity u is 0, therefore half gt square. T is x by u from the first equation. So when we rewrite the expression y equal to s equal to h or y, so y, and we consider x. Now y equal to half g by u square, that is g by 2u square into x square. So this equation is in the form of parabolic equation which is passing through the origin. This equation is in the form of parabolic equation for the body passing through the origin. That is y equal to kx square. Here k is equal to g by 2u square. It is constant. Therefore, path of the we may write path of the projectile is parabola. Now let us do one problem on this topic. So when here consider a body at a height h above the ground, that is s equal to h equal to y, and which is projected with initial velocity u in the horizontal direction at theta equal to 0 degrees in this case. And when the body is moving in the forward direction, its horizontal velocity remains same throughout its path and is not affected by g, but its vertical velocity is affected by g. So at the starting point, its vertical velocity is 0. As it moves, its velocity increases. Velocity is increases as it moves down due to acceleration due to gravity. So from 0 to it increases certain value before touching the ground. Therefore, here horizontal distance travelled is when the body touches the ground from A to C, that is horizontal distance is equal to horizontal velocity into time. Horizontal distance x equal to horizontal velocity into time, general equation. From this, time of journey is t equal to x by u. Now vertical distance travelled by the, on reaching the ground, vertical distance travelled by the body is equal to its height, or s equal to y. So from the equation s equal to half gt square, since ue value is 0 at beginning, so initial velocity is 0, therefore half gt square, t value is x by u from first equation, therefore half g x by u whole square, therefore y is equal to g by 2u square into x square. So in the bracket it should be taken as g by 2u square as constant k, then it may be written as y equal to kx square, which is the parabolic equation of the particle travelling through the origin. Therefore, the above equation resembles the parabolic equation y equal to kx square. Therefore, path of the projectile is a parabola. Now let us do some problems in the next class. If you have any doubt, okay, let us do one more problem. A bomb is dropped from an aeroplane flying horizontally with a velocity of 9.8 meters per second at a height (44.1 meter from the ground. Find when and where the bomb touches the ground. When and where. So here we have to calculate the time of journey. So from the horizontal distance formula, from x equal to u into t, we shall calculate t is equal to x by u, that is here. And from second, y equal to half gt square. That is t square is equal to 2y by g. Yeah, y means h, that is 44.1. Let us take g value as 9.8. Therefore, its value is equal to 9 seconds. 9 seconds squared. Therefore, t is equal to 3 seconds. Therefore, after 3 seconds, it reaches to the ground. In these 3 seconds, it travels the distance of u value 9.8 into 3 seconds. So, therefore, the x equal to 27, 29.4 meters. So here, when it touches the ground, it touches the ground from its starting point 29.4 meters in the x direction, and in 3 seconds, after 3 seconds it travels, it reaches to the ground at point C. That is, from A it travels the distance of 29.4 meters in that 3 seconds. It takes the time 3 seconds to reach the point C. So here vertical distance height s equal to 44.1, y equal to, by substitution, by using the previous equations here, we calculate the first value of time 3 seconds, then we calculate the horizontal range, horizontal distance travelled, that is before touching the earth bomb. It travels from A to C, 29.4 meters. Let us close the class. Let us do some more problems in the coming classes. Therefore, if you have any doubt, you contact me. So